Hi friends, welcome back to my channel Civil Stuff by Waheed. If you are watching my video for the first time, please do subscribe and press the bell button for more updates. So previous classes we have studied regarding the columns and struts and what is the different effective length like that, and Euler's formula also we have derived. And today we'll try to go regarding the Rankines formula and for what type of columns this Rankines formula is useful. And after that we'll try to solve some old question papers pertaining to this chapter, so that it will be completed our columns and struts topic. Coming to here the Rankines-Gordon formula is the Rankines suggested the empirical relationship for the columns which fails by combined effect. Combined means due to direct stresses and due to bending stresses. So how these direct stresses are formed means due to axial loads, and these bending stresses are due to buckling. So there is one relationship, that is 1 by PR equals to 1 by PC plus 1 by PE. So if you solve this one, you will be getting PR equals to PE into PC by PC plus PE. You remember this formula because in the previous exam one of the question will be has been asked from this topic. And here what is this PR? PR is nothing but what? Rankines buckling load. Next, what is PE? Euler's buckling load. And PC is nothing but crushing load. Okay, so the empirical formula, this is the empirical formula and this is the relation, whereas this one is what? Empirical formula. Coming to PR equals to Fc into A by 1 plus alpha. In some textbooks it will be written as A, okay, into effective length by K whole square, L by K whole square. Then what is this Fc? Is nothing but Rankines value for ultimate crushing strength, that is in Newton per mm square, where alpha is nothing but what? Rankines constant. It depends upon the E and Fc values. What is E? Young's modulus of elasticity of the material. And coming to this one, effective length, which is also called as equivalent length, it depends upon the end conditions, like both ends pinned, one end hinged, one end fixed, both end fixed, like that. There are some end conditions, right? Based upon that one you will be choosing. And K is nothing but what? Minimum radius of gyration. So how we will be getting minimum radius of gyration? What is K? Equals to under root of I minimum by A. What is I minimum? You all know. Means minimum of Ixx and Iyy for a particular cross section of the column. For a circular column, Ixx will be equals to Iyy, but remaining for square or rectangular, Ixx will not be equals to Iyy, and where A is nothing but area of cross section of column. Now these are the material, along with that one the ultimate crushing strength value in Newton per mm square and alpha constant value. So I have written in ascending order, only this one I have chosen in ascending order. If I take a timber, it will be having a Fc value of 35. Sometimes actually in our regular classwork problems they will be giving either this one or this one or this one, but because of this being a competitive exam, they will be giving the type of material. You have to choose these values. Okay, so for timber the Fc value is 35 Newton per mm square. For wrought iron it is 250 Newton per mm square. For mild steel 320, medium carbon steel 500, and cast iron 550. Okay. Now coming to the timber, the constant alpha, Rankines constant is 1 by 3000. Next, wrought iron is 1 by 9000. Now mild steel 1 by 7500 and carbon steel 1 by 5000 and what is this one? Cast iron 1 by 1600. So these are the values you are supposed to keep in mind. Okay, don't forget these values. Okay, and coming to the, this is regarding your Rankines formula. Coming to core of a section, core which is also known as a kern or kernel. Now what is this core or kernel of the section means? Suppose if I take a rectangular column, okay, if the load is passing through the point of intersection of both axes, it is called as axial. But due to some errors, either fabrication errors or construction errors, there may be a chances of getting eccentric loading. Now even though if the column is getting eccentric loading, there should be some particular region where it should be free from development of tensile stresses. Now you have to calculate that section where there will be no tensile stresses developed and column will be free to accept the load without getting failed. So see here, core of the section is nothing but it is a region within which if the load is placed, then there will be no tension in the section. Why we are supposed to study means, because for axial loading there will be direct calculations will be there, but for eccentric loading you may be getting a chances of uniaxial conditions and biaxial loading, uniaxial moments and biaxial moments. Suppose if I take a multi-storied building, these corner columns may get a chances of getting biaxial moments, mx and my, like that you may get a chances of biaxial moments. Now why these biaxial moments will be developing means, if the load is not passing through the axial centroid of the section, in those situations only eccentricity may occur. Okay, the main concept of studying this topic is to know the region where no tension is developed while placing the column. So for no tension to develop, the eccentricity E less than or equals to Z by A. Now what is this Z? Section modulus, and A is nothing but what? Cross sectional area. Okay, this is regarding the core and definition of core or kernel. Now we'll see some examples on this. This is the example I am taking, the core of a circular section. Suppose if you have a circular column of diameter D. Now let us consider A as a cross sectional area of cross section. So what is the cross sectional area? Pi by 4 into D square. This is the area of the section. Now for the circular section modulus about x-axis and y-axis will be same. Okay, now what is Z? I by y. Okay, so what is I for a circular section? Moment of inertia pi by 64 d power 4 by what is y? D by 2. So on solving this one, pi by 64 into 2 means you will be getting pi d cube by 32. But for no tension to develop, E should be less than or equals to Z by A. Okay, so here Z pi d cube by 32 by pi d square by 4 means if I am taking like this into 4 by pi d square. So after solving, D is nothing but, you are getting eccentricity equals to D by 8. So this portion from center to here, it is eccentricity D by 8. Because of this circular whole, from this you will be having D by 8, D by 8, D by 8, everything D by 8. So what is the diameter of this one? D by 4. How? D by 8 plus D by 8. So how much it is? 8 D plus D. So 2d by a or d by 4. That is the d by 4. Now dia of core equals to what? This one. This is the region, means in this region, అంటే ఈ రీజన్లో కనుక ఎక్కడ లోడ్ పడినా కూడా మనకు ప్రాబ్లం అనేది ఏం కాదు, కాలం అనేది ఫెయిల్ కాదు. ఓకేనా? Means if load is placed in this region, then no tensile stresses will be developed. Now in a previous question they have previous papers they have one question, what is the dia of the core in terms of radius they have asked. So what is r? R means what? D by 2. Okay, so here what in terms of circular dia they have asked, so d by 4. Okay, half of its radius. What is the dia of core? Means half of its radius. What is radius? D by 2. So d by 2 by 2 means d by 4. Like that you have to solve it. Next, core or kernel of a rectangular section. Now here middle third rule or 1/3 rule we will be calling. Now again we know that for no tension condition E should be less than or equals to Z by A. But because of this being having length and width, that is length of B and width of D, you will be having Zxx separate and Zyy separate. So first you calculate Zxx, means Ixx by y. Ixx means what? B d cube by 12 into y means d by 2 means 2 by d. So you will be getting bd square by 6. Similarly Zyy equals to what? Iyy by db cube by 12. Okay, means db square by 6. This is the section modulus about x axis, about y axis. Next, what is Ex? Z by A, bd square by 6 into what is A of a rectangular section? BD. So what happens? This b dd gets cancelled. You will be remaining with what? D by 6. Means in the depth direction the eccentricity is, means in a y direction it is d by 6 here and d by 6 here. Okay, next what is this? Ey db square by 6 into 1 by bd bd. Okay, so in the width portion it is b by 6 b by 6. Means what is the size? Means it is d by 3, that is the rectangular whose diagonal has been placed as a horizontal, whose major diagonal has been placed as a horizontal. So this is the region where no tension condition is developed. Okay, similarly if you calculate for hollow circular section by the concept of core or kernel for a circular section, you will be getting this one, dia of circular of region, this region, okay, this region, d square plus d square by 4d. Okay, so thank you for watching my video. In the next video I will be solving some problems based upon the columns and struts as per the previous Ecet for both states, Andhra Pradesh and Telangana. Around 10 questions I will be solving. Please watch these videos continuously, previous 2 videos, this video and the next video, so that one chapter will be completed. Okay, so for Telangana it will be around 1 or 2 questions, but for Andhra it will be around 3 to 4 questions from this chapter alone, because for AP students 40 marks are for SM and TS only. Okay.